Good evening, my YouTube viewers. It is Crystal here. I'm here to make you another video. This video is going to be how to create a gamma distribution and test it using Python in Excel. And so if you've been watching my past videos, what I've had to do is I've had to create the actual spreadsheet in a file that I call work in progress. And whenever I finish creating the spreadsheet and the file that I call work in progress, I copy it over to my spreadsheet that has my statistical work in it. And the reason why I have to do that is because Python is just not able to handle a lot of really large work. And I'm certainly not an intellectual dynamo, so I don't think that I put out that much work. But the little bit of work that I do put out is too much for Python and Excel. So Excel can handle a page or two, but it can't handle an entire workbook. And Excel can give you 255 pages or spreadsheets in one workbook, but you can't use that in Python. That's just too much code for Python using Excel. If you paid extra for the higher speed, then you might get more out of it. But obviously I can't pay extra for the higher speed because I'm on a limited income. So before we create our gamma distributions, what you want to do is on the very first page or the very first sheet in your workbook, what you want to do is you want to import the libraries. And you can see I've got all these libraries imported, and it says from scipy.stats import gamma Shapiro. I'm going to take out that, and then I'm just going to click here on the green tick to let you know that it's working. So now it's trying to connect. So now you can see for yourself some of the problems that I have working with Python and Excel, because now it's trying to connect. And so since I went and changed the code and it was trying to connect, then everything in my workbook, gamma dist and test, is had to recalculate it as well. And whenever I finish this video and my blog post, what I will do is I will have to copy this page over to my spreadsheet called my statistics spreadsheet, because I can't have lots of sheets in the workbook because of the limitations of the program. But other than that, I think it's a pretty good program. So first thing we did is we created 3 gamma distributions because I didn't know how many hypothesis tests that I was going to need to perform. So like if I wanted to perform an ANOVA, which I didn't, I would have had to have had 3 distributions, because an ANOVA calculates 3 or more distributions, and I think that there are a few other hypothesis tests that will compute 3 or more distributions. And so since I wasn't sure what hypothesis test I was going to be performing, I decided just to go ahead and make 3 to be on the safe side. So you can see I've got the little gamma distribution in a cell in Excel, and so you can see that. Now I'm okay with that size gamma distribution. You can see that it's right skewed, but if you want the distribution to be bigger, what you would have to do is you would have to take a bunch of cells and then you would have to merge them, and then when you merge the cells, then you could fit a bigger picture in there, but I'm okay with the picture in the cell because what I'm more interested in is the hypothesis test than the actual picture of the distribution. But you can see that the distribution is right skewed. So we look at the code for the first distribution. So for the gamma distribution, it says shape param equals 2, scale param equals 2, sample size equals 1,000. And if you wanted to make the code shorter, you could say shape param, comma, scale param, comma, sample size equals 2 to 1,000. But I didn't do that because I was in a little bit of a hurry this afternoon when I was working on it, and I wanted to get it done as quickly as possible. But if you want to keep the code as short as possible, that's what I would recommend that you do, that I didn't do this time. And then we're going to create the gamma distribution. So gamma equals gamma dot RVS, A equals shape param, scale equals scale param, size equals sample size. And then you plot the distribution using matplotlib.pyplot as PLT, PLT hist, gamma 1, bins equals 30, density equals true, alpha equals 0.6, color equals blue, PLT.title is gamma distribution, X label is value, Y label is frequency, and then you show it. And you can see that you've got your, what you have to do is if you look over there where it says image, there's a little box with a bunch of drawers in it. You click onto that box with the drawers, and then it will give you an option to view the image, and then you click onto the image and the image will come up on the next cell, and that's how you're able to view the image. I wanted to check the means of the 3 gamma distributions, and so you can look here and you can say should say mean 1. Should say mean 1. Mean 1 equals gamma 1 dot mean, and then it should say mean 1. But you can see it's busy now. And see, that's another problem that you have. Every time you do anything, it takes a long time to do it. So that's another problem that you have. And that should say mean 2. So now you get to see, now that I'm making changes to the code, you can see firsthand the problems I have with this and how slow it is. Okay. So you can see that I was in a little bit of a hurry. I did it this afternoon and I had to go out, and I decided that I wanted to do it real quickly before I went out. And so obviously I was in such a hurry that I didn't get to do a lot of the things that normally I would have done. But you can see now you've got your means of your 3. So mean 1 is 3.98, mean 2 is 3.96, mean 3 is 4.1. So that's telling you that the samples are pretty much the same. We check our alpha, which is also your significance level, and it's going to be 0.05. That is 5%. You can set it out to any value that you want. Some people use 0.01, others use 0.05, and other people use 0.1. So you can set it up for the value that you feel most comfortable with, and that's going to be how you're going to perform a null a hypothesis test. And then so the null hypothesis is the samples are the same, and the alternate hypothesis is the samples are not the same. So since we used the same formula, the same code for all 3 distributions, then the means should be the same. And the means, you can see when you check mean 1, mean 2, mean 3, you can see that the means are very close. So now we know that the mean should be the same because we used the code for all 3 distributions. Now we're going to check the Kolmogorov-Smirnov test using 2 samples. And we check the code there. And it's going to be statistic, comma, p-value equals ks2 sample, gamma 1, gamma 2. And then you run up your statistic and your p-value. And you can see that your statistic is 0.034 and your p-value is 0.61. So the p-value is higher than 0.05, so you have to accept the null hypothesis. The Anderson-Darling, it doesn't work on the Anderson-Darling. I checked the Anderson-Darling out on a normal distribution and it worked. So Anderson-Darling works on a normal distribution, but it doesn't work on a gamma distribution. Shapiro-Wilks test, I checked the, it doesn't work either. The only hypothesis test that of the 3 that I selected that works is the Kolmogorov-Smirnov test. And so that's a very good test. If you've been watching my videos, you'll notice that I've been using that test a lot. It's been working a lot. It's a very reliable test, and I use that test a lot. And so just me using it on distributions and checking distributions, you can see it's a very good test to use. One thing about the Kolmogorov-Smirnov test is there is a function to perform on one sample, to do hypothesis tests on one sample, but I did not include that in this video, but I'm sure that you can look it up. It's on Skype, in the SciPy library, I believe. You can look it up, and if you want to perform the test on only one sample, then you can do that if you want. I think it would be like KS a sample instead of KS2 sample. But if you want to perform the test on only one sample, you can do that. So the Anderson-Darlington test didn't work. I'll show you the code even though it didn't work. Statistic p-value equals normal underscore AD, gamma 1 axis equals 0, and then you print the statistic and the p-value, and it gives you a statistic of 19.48, and it gives you a p-value of 0, which isn't correct. So that's just telling you that Anderson-Darling hasn't worked on this particular hypothesis test. But I left it in there just to show it to you. And the Shapiro-Wilks test is stat p-value equals Shapiro, gamma 1, and then you print off your stat and your p-value. Your stat is 0.9, and your p-value is very low level, much lower than 0.05, so it doesn't work either. So on the Anderson-Darling and the Shapiro-Wilks, you get 2 false negatives. And the one that works, that has consistently worked throughout all of these videos I've been making, is the Kolmogorov-Smirnov test. So I've covered everything that I wanted to cover. I've covered the distributions, the means, the alpha, the null hypothesis and alternate hypothesis. I've covered the Kolmogorov-Smirnov test and the Anderson-Darling test and the Shapiro-Wilks test. So I've covered everything that I intended to cover. So I'm going to go ahead and close this video. Thank you so much for watching my video. If you like my video, please like and subscribe, and I will be communicating with you in the next video that I do as well.